पहले डार्क मैटर देखेंगे क्या होता है.
The universe is vast and full of mystery. On large scales, galaxies are being pushed and pulled by gravity. We can map the matter that is responsible. It turns out that most of it we can't see. Most of the matter in the universe is in a form that we know nothing about. It's known as dark matter. On smaller scales, when astronomers observe the movement of stars inside galaxies, their measurements confirm the existence of this dark matter. We only see a small part of what makes up galaxies. Most of them, and indeed most of the universe, is a mystery. We know a huge amount about the ordinary matter that makes up the stars, planets, and everything on them. However, we now know this ordinary luminous matter can only make up around 16% of the matter in the universe. The rest must be made of something new or caused by an unknown phenomenon. Theoretical physicists at Cern are working on new ideas to help understand dark matter. They make predictions that can be tested in the Large Hadron Collider. Does a whole new family of particles exist? And can we detect them in our experiments? Is our understanding of gravity correct? There are many years of data collecting ahead of us. So the Large Hadron Collider will certainly disprove a lot of theories. But perhaps it will also reveal the true identity of dark matter.
Antimatter.
An incredible amount about the history of our universe and how it evolved 13.8 billion years ago. But perhaps one of the biggest mysteries remaining is right at the very beginning. Let's wind back time. As we travel backwards, the universe gets denser. Way back, over 13 billion years ago, the first stars and galaxies were just starting to form. Further back in time, our universe is now only a few 100,000 years old. The first atoms form, and light becomes free to cross the vast expanses of space. This is the origin of the most distant light we can detect today. Now we are back to within trillions of a second of the Big Bang. This soup of fundamental particles provides the basic building blocks of everything we see around us today. And at the very beginning, our universe originated from a point, a huge concentration of energy. The Big Bang. Energy, that's the E in E equals mc squared. Perhaps the most famous equation ever, it can be used to describe how the mass in our universe formed from the huge concentration of energy in the Big Bang. C is the speed of light. A concentration of energy produces equal amounts of matter and antimatter, matter's mirror counterpart. Matter and antimatter are opposites. Put them together and they annihilate. You get back pure energy. And indeed, after the Big Bang, this happened. But not entirely. Almost all the matter and antimatter annihilated, leaving energy in the form of photons. But there was also a tiny bit of matter left over. Why? Well, that is one of the biggest unsolved mysteries in physics. The whole universe formed from this tiny amount of leftover matter. Physicists examine rare particle decays to look for differences between matter and antimatter that could explain the imbalance. It is a mystery that is fundamental to our very existence.
Extra dimensions and gravity.
Gravity is one of the four fundamental forces at work in the universe, and probably the one you know best. But despite its effect being so visible, It's actually the force physicists know the least about. The surprising thing about gravity is that it is so weak. It took the mass of a whole planet to pull that clock to the table. Yet despite atoms being essentially empty space, the forces binding them together in this table are sufficient to keep all the objects suspended. This force, electromagnetism, is around 36 orders of magnitude stronger than gravity. That's a million times stronger. Physicists like finding symmetry in their descriptions of the universe, and this huge difference of scale bothers them. Perhaps gravity is just as strong as other forces, but for some reason, we do not experience its full effect. Theorists try to explain this. Perhaps it is only in our 3 dimensions that gravity appears so weak. Could there be tiny extra dimensions in our universe that we can't perceive? If the strength of gravity was spread across them, only outside them would it appear to be so weak. How could this be? Well, imagine a tiny insect walking around on this grid, so vast it will never reach the edges. It lives in a 2-dimensional world. It can only move up, down, or left, right. It has no idea of the other space dimension that we all experience. Like the ant, just because we don't experience other dimensions in our everyday lives, it doesn't mean they aren't there. And if most of gravity's strength is disappearing across extra dimensions we can't perceive, there might be ways of testing this at the Large Hadron Collider. The particles created by collisions could be just the right scale to explore tiny extra dimensions. Their interactions would leave behind unbalanced, unsymmetric tracks in the experiment. There are already a huge variety of theories relating to both gravity and extra dimensions, but it could take a radical new idea to solve the mystery.
Higgs boson, ये वाला important last. तो basically यही.
The Higgs boson is a new kind of particle discovered by experiments at the Large Hadron Collider in 2012. Its existence was first proposed in the 1960s. It took almost 50 years to discover.
I think we have it. You agree?
This is just the beginning. There's more to come. Second, the LHC and experiments have been doing miracles. They're working beyond design, they're working beyond expectation. We produce a lot of data, a lot of results much faster. So please, particular theorists, be patient. Don't ask us if it's standard or not, how many, etc. Just there is a long path.
Indeed, to fully understand everything the Higgs boson can tell us about the universe will take years of data from the Large Hadron Collider. Since the earliest moments of the universe, all space is filled with an underlying field. The Brout-Englert-Higgs field, or BEH field for short. Stimulating this field with the right concentration of energy, like in collisions at the Large Hadron Collider, creates the Higgs boson. Is the Higgs boson one of a kind? Or are there other particles like it? We can learn more about the Higgs boson by measuring how it interacts with other particles. Studying its properties with higher and higher precision could even reveal the existence of new particles. Interaction with the BEH field determines the fundamental masses of all particles. Each particle interacts with the field in a specific way, giving rise to a wide range of different masses. And physicists want to understand why fundamental particles have this particular range of masses. Indeed, if particles' relative masses were different from what they are, it would have a huge impact on the evolution of the universe and the formation of stars. Chemistry and biology would be vastly different. Perhaps we are simply living in the right universe to ask the questions. Maybe there are an infinite number of parallel universes, covering all possible varieties of parameters of the BEH field, and we are only here to ask such questions because This is the universe where the values allow for our evolution. One thing is sure, the Higgs Boson still has a lot to tell us about the universe we live in.
I think yeah. These are like paper published by Higgs Boson. प्रोटॉन कितना ये है, for example if you want to know Big Bang scenario, इसके बारे में lot of data you can read it out. These are abstracts, wave structure, birth of universe, introduction. These are very interesting topics. Detectors are here. कोलाइड किया, then detection, then analysis. यही सब डिटेक्टर लगा के हर फेज में, समझ रहे हैं ना, ये सारा यूज़ किया गया, प्रोटॉन, इलेक्ट्रॉन, न्यूट्रॉन, न्यूऑन्स, सारा क्वार्ट्ज पार्टिकल्स। और ये हमारा बड़ा सा मैग्नेट कोलाइडर। डिटेक्टर में देखिए भाई लोग, ये है हमारा CMS डिटेक्टर, जो लार्ज हेड्रोन कोलाइडर का एक पार्ट है बोल सकते हैं, पार्टिकल को डिटेक्ट करने के लिए। बहुत ही बड़ा इसमें 10 गुना आयरन यूज़ किया गया था जितना आईफिल टावर में यूज़ हुआ है, आई गेस। IBM 3090 वन ऑफ द Cern's last mainframe on years 1996। हम भी तो mainframe पे ही काम किए भाई। केस फॉर मेरा टेक्नोलॉजी था छोटा, ऐसा मशीन था हम लोग का पहले। बाप रे बाप, mainframe सिस्टम सब डेटा कलेक्ट करने के लिए ये बोल सकते हो एक ऑपरेटिंग सिस्टम था हम लोग का। ग्रीन स्क्रीन अच्छा लग रहा है यार। डिटेक्टर था। स्ट्रिप मेकिंग सेकेंड वर्ल्ड वॉर के बाद ये बनाया था। ये इतना सारा चीज़ स्पेस रेडिएशन से मुझे तो यही इस पे काम किया। डेटा सेंटर लास्ट में देखो कोलैबोरेशन में IT इंडस्ट्रीज में हो। सही है। जो भी होगा वीडियो पॉज करके देख लेगा। नहीं, ये सब मेजर एक्सपेरिमेंट्स हैं। 1932 में ये तो नॉर्मल चल रहा है। सारे एक्सपेरिमेंट थोड़ा देखना पड़ेगा डिटेल में।
बहुत कुछ एक्सपेरिमेंट हुआ तब जाके ये फाइनल हुआ।
देखिए कितने चिप लगे हुए हैं इसमें। इधर से निकल जेनेवा सर्न में आपका स्वागत है। आइए घूमते हैं। भास्कराचार्य द्वितीय नक्षत्र वर्ष लंबाई का माप। और अच्छा और फिल कर रहे हैं सारे मंत्र। सारे आज़ाद शंकर माधव शंकर सही है, नाम भी है इसमें। बीटा रेडिएशन रदरफोर्ड मेडी नई थियरी जो इलेक्ट्रोमैग्नेटिज्म सही है। रिजिड थॉमसन एविडेंस ऑफ द एग्जिस्टेंस ऑफ इलेक्ट्रॉन रेडियोएक्टिव वेरी गुड यूनिक सेट है। Universe of particles, okay. That side.
एक शो होता है यहाँ पे ठीक है
Universe of particles अच्छा बना है। सी मिशन मंडे टू सैटरडे 10 से 5
ये मूवी है हर एक घंटे का तो अभी 12:15 बजे फ्री है होने अब सवाई हेलो खूब दिख गया मुझे यहाँ पे।
तो हम लोग उतर गए हैं नेशंस के बस स्टॉप पे। क्यों नेशंस बोला जाता पता नहीं, मैं भी यहाँ पे कुछ नेशंस के यूनाइटेड नेशंस के क्वार्टर्स हैं और ये फेमस चेयर है जो कि 3 पिलर्स दिखाता है अपने
इंडिया का फ्लैग भी होगा।
जी हाँ इट्स ह्यूज। जी हाँ हम देख सकते हैं एलियंस का इंडिया का फ्लैग ढूंढो भाई लोग। मुझे तो दिख गया बता दे। जिनेवा में यूनाइटेड नेशंस के सामने यहीं पीछे बोलेंगे एक गार्डन है, और यहाँ महात्मा गांधी का एक स्टैचू है, बेचारे मैं ध्यान में बैठे हुए हैं। अच्छा लगा इनको देख के यहाँ पे, चूँकि ये पीस के प्रतीक माने जाते हैं, शांति के, और यूनाइटेड नेशन भी इसी के लिए ही बना था, शांति कायम रखने के लिए पूरे दुनिया में। तो उनके याद में उनका पुतला बनाया गया है यहाँ पे। बाकी अच्छा है, साफ सुथरा, पतझड़ है, फॉल का टाइम, इसलिए गार्डन ठीक ही है। पीछे एक आई गेस कोई वो एक म्यूज़ियम है। चलिए मिलते हैं। अच्छा है, भाई लोग आ गए हैं जिनेवा में, और वहाँ एक फाउंटेन चलता है, लेकिन अभी ठंडा के चलते बंद किया हुआ है। एग्जैक्टली वही जगह पे, क्योंकि 140 फीट ऊंचा पानी को फेंकता है, और पर सेकंड अराउंड 500 लीटर्स पानी जाता है, लेकिन अभी बंद है। कोई नहीं, ये है जिनेवा लेक, देख सकते हैं क्लियर पानी है, और कुछ ज़्यादा ही क्लियर है। अंदर के पत्थर को देख सकते हैं, गहरा है लेकिन दिखाई दे रहा पत्थर। अच्छा नज़ारा है। चलिए चलते हैं। यहाँ का नाइट लाइफ फेमस है, ब्रांड, हर एक ब्रांड के आपको जितने भी ब्रांड हैं। इसका ठंड है, क्रिसमस ट्री भी है, बढ़िया है।
भाई स्नोफॉल चालू हो गया फाइनली।
जिनेवा में यार बहुत
सब जाती है।
डेकोरेशन पूरा इंडियन स्टाइल में,
राजस्थानी स्टाइल
बोल सकते हो। मुगल वाला भी लुक दिया थोड़ा बहुत।
थोड़ा मिक्स है एक्चुअली, राजस्थानी है,